My name is Mary Meyer, and my research study focused on PA12 using the SLS additive manufacturing process for thermoplastics. The research study that I focused on was the influence of powder deposition on powder bed and specimen properties. And this study focused on the powder bed fusion processes, especially those focusing on SLS or selective laser sintering. And that's described as having the highest potential for breaking the barrier of rapid prototyping or for additive manufacturing. The key questions addressed were to investigate the effects of powder deposition with 3 different blade geometries on surface roughness. Some of the mechanical properties and the effects of for this powder are not as well known, and so the study is hoping to solve that. For the experimental approach, of course, as I said before, the materials used are the focus on that PA12 powder. The process conditions examined were the surface quality of the component, as well as the mechanical properties. PA12 powder is a widely used polymer in SLS, and with that, the mechanical properties to be focused on for this study are going to be the tensile strength, Young's modulus, and fracture strain. And the characterization tools adopted are the SLS 3D printing. The key results from part of the study are going to focus on surface roughness due to blade shape. So this is just a comparison of the different blades that were used during the study. The flat blade, as you can see, caused the lowest roughness, and that's due to a higher compression as a result of a larger contact zone between the blade and the powder bed. These other graphs here show the effects of the surface roughness for the other different kinds of shapes. But overall, it's concluded that the surface quality of a powder bed is influenced by the shape of the blade used. Second question was how will the powder bed fusion processes, especially for SLS, affect the mechanical properties? All in all, specimens made from the low-cost SLS system don't have inferior quality compared to the industrial machines used in traditional manufacturing, but they need to be placed in the right build orientation in correspondence with powder definition for the best mechanical properties is essential. They can be affected due to the direction of the powder deposition, but again, not the surface quality of the powder bed. The key conclusions from my research paper were that the surface quality of a powder bed is affected by the shape of the blade used in the power application, as we saw in the first key research question. In the second key research question, we saw that the mechanical properties can be affected due to the direction of the powder deposition, but not the surface quality of the powder bed. And the results are favorable for additive manufacturing, and they should be further researched. The writers of the paper did a really great job of including an outlook section, which I thought was very helpful in my critique of the paper, and really showed kind of the mindset that they had going forward and the direction in which they thought that this should go in, and what might be useful for others looking into this process.